We're going to evaluate these using the unit circle. So first I'm going to draw just the first quadrant of the unit circle because I really don't need the rest. I can just use the first quadrant as a reference for all the other quadrants in the unit circle. I'm going to label the radians. This is 0 radians, and then here is pi over 2 radians. Halfway between those is pi over 4, because that's half of a half, so a quarter. And then I have these other special angles, pi over 6 and pi over 3. And then I want to label the coordinates for those. So at 0 radians, the radius of the unit circle is 1, so you go over 1, up 0, and then at pi over 2 radians is 0, up 1. For the other coordinates, let's start with pi over 6. So that comes from a special right triangle where you go over and then up. It comes from the 30, 60, 90 special right triangle. And this x distance, this horizontal distance that we're going over, is root 3 over 2. And then you go up this shorter distance, which is a half. Pi over 3 is just the inverse of that, so 1/2 root 3 over 2. And then pi over 4 comes from a 45, 45, 90 triangle. You go over and up the same distance, and those distances are root 2 over 2. Okay, so I'm going to use that as a reference for evaluating each of these trig functions. So first, sine of pi over 4. The other thing that I need to know is that cosine of an angle is the x value for the coordinate of that angle. Sine of an angle is the y value, and tangent is the y value. Tangent of theta is the y value divided by the x value. So if I want sine of pi over 4, I'm going to go to pi over 4 on my unit circle and look at the y value. It's root 2 over 2. So now I'm going to try number 2, cosine of 2 pi over 3. 2 pi over 3 is not in the first quadrant, so I'm just going to sketch what it looks like, what quadrant it's in. So here's 0 radians, pi radians. So 2/3 of a pi, I'm going to go 2/3 of the way to pi about there, 2 pi over 3. The reference angle for that is just here, pi over 3, 1/3 of a pi. I went 2/3, so what's left to get to the x-axis is pi over 3. So then I'm going to go to my first quadrant that I drew of the unit circle and look at pi over 3 here. Cosine is the x value, which is a half. The only thing I need to check is whether my answer should be positive or negative. So since I was in the second quadrant, the x value is negative in the second quadrant and the y value is positive. Since I was using the x value, because this is cosine, my answer should actually be negative 1/2. All right, I'm going to try number 3, tangent of 7 pi over 6. So I'm going to start doing the same thing. I'm just going to sketch so I can see what quadrant it's in. So here's 0 radians, pi radians, 7 pi over 6. So that's 1 1/6 of a pi. 1 whole pi plus another 1/6. I need to find my reference angle, which is just here. That distance was just 1/6 pi over 6. So I'm going to go to the first quadrant and look at pi over 6. Tangent says to take the y value and divide by the x value. So I'm going to take 1/2 over root 3 over 2 divided by root 3 over 2. So I need to simplify that. That's the same thing as 1/2 times the reciprocal, 2 over root 3. The 2's cancel out and I get 1 over root 3. But the only problem is you can't have a square root in the denominator for your answers in math. So I'm going to multiply the numerator and denominator by the same square root, square root of 3. 1 times square root of 3 for the numerator is just square root of 3. And for the denominator, square root of 3 times square root of 3 is square root of 9, which is just 3. So my answer is root 3 over 3. I just want to double check if my answer should be positive or negative. I was in the third quadrant where the x value is negative and the y value is negative. So I was really doing a negative divided by a negative. So my answer is still positive because a negative divided by a negative is positive. Okay, finally I'm going to do secant of 5 pi over 4. So secant is actually the reciprocal of cosine. So if I could figure out what cosine of 5 pi over 4 is, I just do the reciprocal of that. So first I'm going to sketch where 5 pi over 4 is. 0 and pi. So 5 pi over 4 is 5 over 4 is 1 and 1/4 of a pi. Let's go 1 and 1/4 down here. I need to find my reference angle, which is pi over 4. So I'm going to go to the first quadrant, go to pi over 4. I'm going to figure out what cosine of 5 or pi over 4 is. So cosine, you look at the x value of the coordinate, is root 2 over 2. But since it's actually secant, which is the reciprocal of cosine, I'm going to flip that over and make it 2 over root 2. So again, I can't have a square root in the denominator. So I'm going to take 2 over root 2 and multiply the numerator and the denominator by root 2. I get 2 over root 2 for the numerator, or 2 times root 2 for the numerator. The denominator is square root of 2 times square root of 2, which is just 2. And these 2's are going to cancel out, and I just get square root of 2. I'm going to double check if my answer should be positive or negative. Since I was in the third quadrant, x is negative and y is negative. I was using the x value because I was looking at cosine to find secant, so my answer should be negative. Okay, now we're going to try ones where we're actually working backwards. It says find all values of theta where it says 0 is less than or equal to theta is less than or equal to 2 pi. That means theta is between 0 and 2 pi. It means on our unit circle. I want to find all the values of theta, the angle, where sine of that angle is negative root 3 over 2. So I just pasted my sketch of the first quadrant of the unit circle. And I'm going to look where sine of theta, which is the y value, I'm looking for where the y value is root 3 over 2, because sine of theta is the y value. So that happens here at pi over 3. Now I'm going to try to figure out which angles in the unit circle have pi over 3 as a reference angle. So if I just start counting by pi over 3, thirds of a pi over 3, if I go another, so that's 1 pi over 3. If I go another third, I get 2 pi over 3. If I go another third of a pi, I get 3 pi over 3, which is 1 whole pi. If I count another third, 4 pi over 3. If I count another third, 5 pi over 3. And then another third of a pi completes the whole circle. I get 6 pi over 3, which is just the same as 2 pi. That's all the way around the circle. So 2 pi over 3, 4 pi over 3, and 5 pi over 3 all have pi over 3 as a reference angle, and they're all going to have root 3 over 2. They're all going to have the same coordinate. They'll all be 1/2 root 3 over 2. But the only thing that changes is the signs. So in the first quadrant, x and y are positive. In the second quadrant, the x is negative, the y is positive. In the third quadrant, they're both negative, negative 1/2, negative root 3 over 2. And in the fourth quadrant, the x is positive, the y is negative. So it's asking when I get a negative root 3 over 2. That happens in the third and the fourth quadrant is when the y value is negative. So these angles are my answer, 4 pi over 3 and 5 pi over 3. All right, we're going to do one more problem. I'm going to try the same type of problem, but I want tangent of the angle is root 3. Tangent is you take the y value and divide by the x value. So I need to figure out when I take y and divide by x and I get a square root of 3. I just pasted my picture of the first quadrant again so I can look at the coordinates. And I'm just going to try taking, for example, this one and see if when I divide y by x, because that's what tangent is, if I get root 3. So I'm going to try 1/2 divided by root 3 over 2. So that's the same thing as 1/2 times the reciprocal 2 over root 3. The 2's are going to cancel out. I get 1 over root 3. Remember, I can't have a square root in the denominator, so I'm going to multiply the numerator and the denominator by square root of 3. I get 1 times root 3 for the numerator, and square root of 3 times square root of 3 is 3 in the denominator. That did not give me square root of 3. So then I'm going to try this coordinate instead and just flip it. If I do root 3 over 2 divided by 1/2 and see if that works. Root 3 over 2 divided by 1/2. That's the same as root 3 over 2 times the reciprocal of 1/2, which is 2 over 1. My 2's cancel out, and yay, I get a root 3, which is what I wanted. So that happened at the angle of pi over 3. But is there another time where I get the same coordinate, and I take root 3, the y value is root 3 over 2, and divide by an x value of 1/2? That would also happen. So pi over 3, kind of like the last problem we were just looking at, 2 pi over 3, 4 pi over 3, and 5 pi over 3 all have these same coordinates. But if I do 2 pi over 3, the x value is negative and the y value is positive. I'm going to get a negative answer if I divide those. Same thing in the fourth quadrant. The x value would be positive, the y value would be negative, and if I divide those, I'm going to get a negative. But in the third quadrant right here, they're both negative. So if I divide a negative by a negative, I'm still going to get a positive root 3, which is what I want. So also in the fourth quadrant, 4 pi over 3, I'm going to get the same tangent of that angle. 4 pi over 3 would be my other answer. And that's it.